Hello everyone, welcome to the third session of our learning on best practices and techniques for functions. In the previous sections, we learned about the different types of functions in FindBI, as well as the common functions in each type, including their usage scenarios and methods. After learning about functions, the goal is to apply them to our analysis when calculating business indicators. Here, we'll summarize, through a practical case, how we can choose the right function for a business scenario, how to use it correctly, and how to verify the accuracy of the calculation fields. Now, let's take the example of user retention analysis, which is a scenario that's easy to understand, to help you grasp the process. The first step is to clarify the business needs, which is always the starting point for any analysis. In this case, the operations team wants to analyze the daily active users, daily retention rate, next-day retention rate, and 3-week retention rate, based on user activation and login data. This is important for the development of the next user operation strategy. If you're the operations person or a data analyst assisting them with this analysis, at this stage, we need to understand the background and the data structure of the table. We also need to be clear about the definitions of the indicators. For example, when the operations person mentions retention rate, we need to understand what that means and how it's calculated. We need to come to a consensus on this at this stage, including the definitions of 3-day, 4-day, and 3-week retention, and whether the end-day retention refers to the day after registration or includes the registration day itself. This will help us maintain consistency in business terminology during calculations and avoid any ambiguity. So, after understanding this, the second step is to outline our calculation steps. Once we have this table, let's first take a look. This is the table I've loaded, and I preloaded it for you. It will be attached in FindBI later. It contains the login time, the earliest activation date, cooperation status, service staff, and so on. We need to be clear about the meaning of each field from the start. The second step is to organize the calculation steps. Initially, after we understand the meanings of the fields, the next step is to check if these fields are standardized or if we need to clean them. Then, we need to organize our calculation logic. According to the requirements above, we need to first calculate something, and then calculate the next thing in sequence. For example, we first calculate the daily active user count, then calculate the time interval. After calculating the time interval, we can calculate the number of retained users, and then the retention rate, and so on. There is a sequence of steps to follow, and we need to organize them clearly. The third step is to find the appropriate function. The first method is to write associations. For example, the date interval, we simply remember that subtracting one date from another gives the date interval. Or when calculating the number of logins, the count function is used. We start with the association and spell out count, then check the recommended options. This is the first method. The second method is to search in the left side list. For example, if I add a calculated field, I can see which date and function types are available, or we can search here and check the recommendations. The third step is to search in the help documentation. We can use keywords or functions to search. For example, if I want to find the time interval, I search for time interval, or if I want to find the count function, I search for count or distinct count, and it will recommend the appropriate function. After we roughly identify the correct function, the fourth step is to use the function correctly. To use it correctly, the first method is to refer to the function definition for helpful tips. The second method is to check if the formula is valid. Alright, let's now move into the analysis. We've just organized our calculation steps. The first step is to calculate the number of new users, or you can first calculate the time interval, whichever you prefer. The table that's been exported here provides the time interval. But let's assume this field is not included in the export, which is usually the case. So, how do we calculate it? We've previously introduced 3 methods for this. The first method is through a quick function for time interval when editing data. The second method is to write the function ourselves. If we're calculating the time interval in days, there are two common ways to do it. One of the data cleaning tasks we often encounter is deduplication. Here, we can use a group summary method for deduplication, save and update it. Now, let's enter the component section. We'll calculate the indicators mentioned earlier. First, we add a calculation field. This is where we write the function. The first indicator we're calculating is the number of new users, such as the number of new users on a given day or week. As mentioned earlier, the function we use for counting is countDAGG. We'll drag the phone number here, because the phone number is the unique identifier for each user, and we'll deduplicate based on the phone number. This gives us the number of new users. You can see the function's definition. I'd like to emphasize here that we cannot write this function when editing data. For instance, if we add a formula and input the count_ag function, you'll see that it says aggregation functions are not directly supported here. This is because the deduplication happens based on the current analysis dimension and the returned fields. When performing calculations within a component, the function will not work until the specified dimension is included. So, we need to drag in the earliest activation date and the calculation field to get the correct result. Now that the dimension has been added, the data value is displayed. As we change the granularity of the dimension, the number of new users will also change accordingly. This is because the aggregation is done dynamically based on the specified dimension. Now, let's calculate the retention rate for the day. The definition of the daily retention rate is the number of retained users divided by the number of new users for the day. How do we calculate the number of retained users for the day? We also use the countDAGG function. But we don't just count all users, we apply conditions to determine which users are considered retained on that day. For instance, we can use the activation and login time interval, and directly use this field. To make it a bit more complex, we could use a formula. If we haven't calculated this step earlier, we can directly use the datesUpdate function in the formula. This function compares the login time and the earliest activation time, and there's one more parameter we shouldn't forget. The third indicator we need to calculate is based on time, right? It's currently calculated by days. When the time interval equals 0, we conclude the calculation based on the phone number to confirm the result. If the time interval is not 0, then we don't end it and simply input null. Let's take a look at how the parameters of the function are used here. Apart from that, the denominator, which is the number of new users, also needs to be calculated. We can simply divide the two numbers or directly copy the formula from earlier for a one-step calculation. Now, let's save and calculate the daily retention rate. Next, we'll calculate the next day retention rate, which is relatively easier. We can directly copy the formula and change it to calculate the next day retention rate. The time interval for the next day is 1. We just need to modify that and it'll be done. These two calculations are straightforward. The third indicator is the weekly retention rate. This one requires more attention. The weekly retention rate refers to the number of users retained within a week, and it has a specific definition. We need to calculate it according to this definition. Let's check the definition here. The number of retained users within n weeks refers to the time interval between registration and login, which is between 1 and 7 days for 1 week. So, for 1 week, the time interval will be greater than or equal to 1 and less than or equal to 7. For 3 weeks, it'll be greater than or equal to 1 and less than or equal to 21, and so on. For the weekly retention rate, we can also copy the previous formula since we are using some of the same fields. We'll just modify it to reflect the weekly retention rate. Since the previous time interval was equal to 1, now we need to set it to greater than or equal to 1 and less than or equal to 7. We can use logical operators, like the AND operator, which I haven't demonstrated much before but will introduce to you now. It will ensure the condition is between greater than or equal to 1 and less than or equal to 7. Make sure to use the correct symbols for greater than or equal to and less than or equal to. These symbols are different from writing them manually. Okay, let's take a look at the AND operator here. For the weekly retention rate, if we want to calculate the 3-week retention rate, we can simply copy the formula and make slight adjustments. For example, the retention period for 3 weeks would be 1 to 21, so we change the value to 21. This is based on the indicator definition we determined earlier. Of course, your retention rate calculation may differ, but this method is based on a predefined condition. Now, let's drag both the 1-week and 3-week retention rates into the analysis. To make it easier for us to display, we can present the data in the form of a graph. Additionally, let me share some extra knowledge on the new user count field. Apart from using the count.DAGG aggregation function, we can also directly use the indicator count, which is automatically generated by our component. By default, it represents the total number of rows in the data. For example, here it shows 19,869 rows. If we want to remove duplicates, we can use the phone number to eliminate them, and you'll see that the result matches the one calculated earlier. For clarity, let's change the representation to a bar chart for the new user count. Since both metrics share the same axis, the data values may differ significantly. To improve this, we can modify the axis scale to only reflect the relevant data, and now the chart looks much better. Let's drag the new user count into the labels for easier identification. Similarly, we click to modify the attributes of the line chart to highlight the data points. At this point, we still haven't finished. You may be concerned whether the data is accurate, so we need to perform a simple validation. There are several ways to validate, and I'll show you one method. For better validation, we can switch to a finer granularity. For instance, let's select a specific date, such as January 3, 2020. To validate the data, we'll apply a filter. I've previously introduced this method in our data editing session. Using this approach allows us to view the changes after the filtering step without affecting the final result. We'll select the earliest activation date as January 3, 2020. After applying the filter, we see there are 24 records, which means there are 24 new users. Next, we'll add another condition for the login time interval to be 0, which means the users logged in on the same day. This results in 20 users, so the daily retention rate is 20 divided by 24, which gives 0.83, or 83%. We can verify this with a calculator and it confirms the value is correct, rounded to 2 decimal places. We can also check the next day retention rate by changing the condition to 1. Testing this gives us 1/24, which is also correct. If you're still unsure, you can verify other data points. This is one of the methods we use for data validation. Once we're confident in the accuracy of the data, we can share the results with the operations team. Alternatively, if we're conducting the analysis ourselves, we can look at trends, such as any decline in daily retention, and make adjustments to our operational strategies based on those insights. Alright, let's summarize the 5-step best practices for using functions. Step 1. Clarify business needs. This is the most important step. Understanding the business context, the background, the data, and defining the indicator clearly is crucial. Different indicators' definitions may lead to different results, even if the name of the metric is the same. The correctness of everything we do later on depends on this. Step 2. Outline calculation steps. Once we've defined the business needs, we need to break down the steps. What should be calculated first? What should follow? Each step should be clearly defined, so we know exactly how to proceed and what functions we need. For example, if we want to count new users, we should choose an appropriate counting function, or if we're dealing with time intervals, we should select the correct function based on the steps. Step 3. Identify suitable functions. How do we find the right function? One method is writing and recalling from memory. Familiar functions, such as time interval or count functions, can often be remembered just by writing them out. Another method is selecting based on the field type if you forget the exact function but know what type it is. The third method is referring to documentation. In the previous slides, I've shared help documentation that outlines the function types and suitable scenarios. You can search for specific keywords in the documentation to unlock the correct function. Step 4. Proper use of the functions. This step emphasizes applying the function properly. It's straightforward, but ensuring you use the function as intended is critical. Step 5. Function validation. Once you've applied the function, it's essential to verify its accuracy. There are several validation methods. Random sampling method. Summation method. Some indicators must add up to 100%, or you may need to check if the average calculation is correct. Onion peeling method. If the function is nested, start from the inside out and check each layer. For those who have written code before, this method is familiar. You check the logic layer by layer to ensure everything is correct. If each layer is right and only passes parameters to the next layer, then the overall logic is correct. So, that's the best practice for using functions. I hope you can apply this method to your actual business analysis. I believe it will be helpful to everyone. Thank you.